All right, my mathletes, how's everybody doing out there in Math Magic Land today? This is Mr. Muscarella coming at you, and we're going to take a look at another video of how to graph an absolute value function as a piecewise function. So let's go ahead and take a look at example number 2. All right, so when we go to take a look at example 2, yeah, there we are right there, coolio. All right, so we've got to graph this and figure out what the piecewise function is. So the goal of this problem is to take this equation right here, this absolute value equation, and write it as a piecewise defined function. So that's what we're going to try to do. And to do that, we're going to analyze a couple things about our function. Now, the very first things that we're going to want to analyze are the a, h, and k that are located within our function. Now, the a value is -1, which tells me that my absolute value function is going to open down. So generally speaking, it's going to be a v that is shaped like that. Now, the h and the k value, this is where the h value can get really tricky because there's nothing in there besides just an x, which means your h value is just 0. And 0 doesn't have an opposite. It's neither positive nor negative, so we don't have to worry about that. So if there's nothing on the inside like that, your h value is just 0. And the k value is outside of the absolute value on the right-hand side, and that's +1, which tells me my vertex is 0, 1. So I'm going to go ahead, put a dot right there on my vertex at 0, 1. Now remember, my h value is also the number that's going to go in here for my absolute value function when I write it as a piecewise function. So that first half is done. Now, here's where I've got to pay attention because my a value is -1, which means it's open down. So from the vertex, I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, because I have a slope that is negative. Now, conversely, I'm going to go ahead and go down 1, but to the left 1, down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. So you're going to do this all the way to the edge of the graph. And then, of course, draw our straight line to make it look like a V. So each side, so on the right-hand side, that's where my slope is going to be -1. And on the left-hand side, that's where my slope is going to be +1, because I can take any 2 points. If I do the rise over run or calculate their slope algebraically, I will get a slope of 1 on the left and a slope of -1 on the right. Now, with that said, let's go ahead and put together this absolute value function, this wonderful absolute value function as a piecewise function. So the left piece always goes on top. So I know my slope on that side is 1, so I'm just going to write x, because we don't write a 1 in front of the x. And then I can tell from the graph, so I just have to look at the graph and I can tell that the y-intercept is right at 0, 1. So since 0, 1 is my y-intercept, that's just going to be +1. So boom, that was easy. I didn't even really have to do anything with that. Now when I look at the left-hand side, I came up with the equation x + 1. The right-hand side is going to be very similar, but remember, the slopes are opposite. So if the slope on the left side was 1x, that means the slope on the right-hand side is going to be -1x, or just -x. Now this one, again, they both meet at the same y-intercept in this case, so that's pretty cool. The only thing I have to do is just also have that as +1. So boom, diggity done. We got everything from looking at that graph. But I want to double check to make sure I did not make a mistake. So we're going to do this algebraically also. So algebraically, I'm going to pick one of the points on here and say, I'm going to pick this point right here, which is -2, -1. So I'm going to use this point on the left-hand side. Now remember, we're going to start to write this as y equals mx plus b. So that's going to be the first thing we're going to do, is write it in slope-intercept form. Now, I know my x and y values, so I'm going to substitute those in. So -1 is going to go for my y. Now the slope, remember my two slopes, on the left-hand side, my slope is 1. The x value, if I look at my point, my x value is -2. And then the b value is the part that I'm trying to figure out. Now when I multiply 1 and -2, that gives me -2. So on the right side, I'll have -2 plus b. On the left side, I'll still have -2. If I slide over the -2 by adding 2 to both sides, I will get 1 for the value of b. So I'm going to put two pieces together. I'm going to take my slope value that I know is 1. So I'm going to write this as the equation y equals x, and then the b value that I got was plus 1. And then I want to check, does this match over here? Yes, it does match. So matchy is good. Now I'm going to do this similar thing. I'm going to do something similar on the right-hand side and say I'm going to take this guy right here, and that's a point 3, -2. So 3, -2. That's going to be my point. 3, -2. And I know the slope on the right-hand side, that slope is going to be -1. So again, write down y equals mx plus b. If my slope is -1, my m value is -1, my x value is 3, b we're trying to find, and my y value is -2. So these are all just substitutions. Once we make the substitution, arithmetic is going to be our very best friend. -1 times 3 is 3 plus b, and then when you move the 3 over, you are going to, -3. When you move the -3 over, then that's going to add 3 to both sides, which gives you 1 for the value of b. So when I write this equation, my b value is going to be plus 1, and I already know my slope value is -1, so that's going to be -x plus 1, and then does this match the bottom part of my piecewise defined function? And yes, it does. So that's how I can do this problem both algebraically and graphically. So bomb diggity boom, done, we out. Be sure to check out the next video where it's not quite so easy as these first two have been. That's it. Thanks for watching this example. I'll catch you later. Peace out.